So this is a video of the fourth math assignment in which we have to find the volume of a donut generated by revolving the disk of radius r centered at point r0 about the y-axis. So first of all, we're going to start by drawing a picture on a coordinate plane. So we have a circle, or a disk, centered at r0 and points r plus r, r minus r, and this is our little r, which is our radius. So first of all, we're going to start by solving for, we have x minus r squared plus y squared equals r squared. And we're going to solve for x, since this is being revolved around the y-axis. So we can have this in terms of y. So if you take the square root of both sides, you get x minus r plus y squared equals r. And now you're going to get x equals big R plus or minus r squared minus y squared. Okay. So going from here, you're going to do an integral for this plus and an integral for the minus situation. So the first integral we have is pi times the radius from negative r to r of r, big R, plus r squared minus y squared dy. And I'm just going to erase this for room's sake. And we're going to go ahead and do this at the top just so we have room for everything. So we're going to do pi r negative r plus root r squared minus y squared dy minus pi negative r to r big R minus r squared minus y squared dy. So you see we have the plus situation and the minus situation from the root. Now this goes to pi r negative r. Now I'm just going to expand it out. So you get r squared plus 2r root r squared minus y squared plus r squared minus y squared minus pi negative r to r squared minus 2r r squared minus y squared plus r squared minus y squared. Just got a little cramped at the end. But now if you see, this r squared is going to cancel with this r squared because it's plus and minus. This is going to cancel with this because it's plus and minus. So you're going to be able to simplify this down to pi integral from negative r to r of 4r, which is 2r plus the 2r, r squared minus y squared dy. So now you have, this is a constant, so we're going to take this out, 4 pi r integral negative r to r squared minus y squared dy. So now this is going to look familiar. This is because this is the same integral we used to find the equation for the area of a circle earlier in an earlier unit. So now I'm going to go to the side and draw a triangle to solve this. So this is going to be r, this is going to be y, r squared minus y squared. So this means y equals r cosine theta, and dy equals negative r cosine theta, sine theta, and r squared minus y squared is equal to r sine theta. So now we're going to go back over to our integral, and this is now equal to, we can substitute it with the equations that we just found over here, and found that 4 pi r minus, going from pi to 0, negative. Oh. This is times like a negative. R squared sine squared theta d theta. So that's with our substitution. Now we're going to get rid of this negative number by flipping the limits of integration and doing 0 to pi of r squared sine squared theta d theta. Now, this r squared we're going to pull out by r squared over 2, doing pi to 0. And we're going to use the Pythagorean identity to turn this into 1 minus cosine 2 theta d theta. And this turns into, if we take the integral of that, theta minus sine 2 theta over 2 from pi to 0, or 0 to pi. 1/2 area, which is what we were solving for with this integral right here, is equal to pi r squared over 2, where area equals pi r squared. As we all know, that's the area of a circle. So now we're going to take this and multiply it by this original constant right here, or this, I guess, would be the most recent. Because this integral right here is where we found the pi r squared. So now we're going to multiply that by the 4 pi r that we had originally as our constant. And we get 4 r, big R, pi squared r squared. And that's your final solution.